In this presentation, what we're going to do is we are going to look at ratio calculations related to the ratio test. We're actually not going to do the ratio test in this example. What I'm going to do is state the general term here, u of n. Okay, that's the general term of a sequence. Okay, so you're given that, and essentially what you have to do is state u of n plus 1. So it's the term that comes after u of n. It's the u of n plus 1. And then what we're going to do is determine u of n plus 1 divided by u of n. Okay, so that's the sort of ratio that we're going to calculate. So the first example is, let me find it down here. We are going to calculate, this is u of n, so u of n plus 1 is essentially where we have n, just put in n plus 1. Okay, so essentially we have n here, so u of n plus 1 is just replace n with n plus 1. Now we can simplify this expression. This is 2 times n times 2 to the 1 using power laws. So in other words, 2 times 2 to the n. Okay, and therefore u of n plus 1 divided by u of n equals 2 times 2 to the n over 2 to the n, and that gives us 2. Okay, so that's all we're doing here really. So let's move on to the next one. U of n equals n factorial. So n factorial, just in case you don't know, is n times n minus 1 times n minus 2 and so on. And so on till we get to times 1. Okay, that's not supposed to be there. Okay, just as a quick example, 5 factorial is 5 by 4 by 3 by 2 by 1. Just as a quick remark, 5 factorial is equal to 5 times 4 factorial. N factorial is equal to n times n minus 1 factorial, and n plus 1 factorial is equal to n plus 1 times n factorial. Okay, so those are all sort of useful things to know. In fact, I've already stated the answer there. U of n is u of n plus 1 is n plus 1 factorial. Just replace n from up here with n plus 1. Okay, so we replace n with n plus 1 there. Now we can rewrite that as n plus 1 times n factorial. Okay, so when we divide it out, u of n plus 1 divided by u of n, that is n plus 1 factorial divided by n factorial, which is n plus 1 times n factorial over n factorial. And those two n factorials cancel out. So essentially what we have is our ratio works out to be simply n plus 1. Okay, so that's the ratio there, n plus 1. So it's u of n plus 1 divided by u of n. Okay, third example, we're moving along quite nicely. N factorial divided by 2 to the n. Okay, so this is using the last two examples together and expressing them as a fraction. So u of n plus 1 is n plus 1 factorial over 2 to the n plus 1. Okay, now the ratio is a little bit tricky. So u of n plus 1 divided by u of n can be expressed as u of n plus 1 times 1 over u to the n. So essentially you invert it, you flip it upside down, express it as a fraction, and just switch the numerator and denominator. So essentially in this case what we have here is n plus 1 factorial, okay, divided by 2 to the n plus 1 by 1 over u to the n. So essentially what we're going to do is invert u to the n there, or u of n, okay, so we're going to have 2 over n factorial. Okay, essentially just invert this up there. Okay, now we're going to use cancel out. I'm going to re-express this part here in terms of what we learned from the first example. Okay, so I'm just going to rewrite that part. So that is n plus 1 times n factorial over 2 times 2 to the n. Okay, so 2 to the n cancels out with 2 to the n factorial cancels out with n factorial. So what we're left with is n plus 1 over 2. So that is the ratio in this case. Okay, so moving on to the next one. Now this is a little bit tricky. So u of n plus 1 equals n plus 1 factorial times n plus 1 factorial. Okay, now in this case, what we're going to say is that that's as simple as, or actually I'll just write it like this. It's n plus 1 times n factorial times n plus 1 times n factorial. Okay, or we could rewrite that as n plus 1 squared times n factorial times n factorial. And when we get the ratio u of n plus 1 divided by u of n, that is simply n plus 1 squared times n factorial times n factorial all over n factorial times n factorial. And again, you can see here that the n factorials all cancel out with each other. So the answer we are left with is n plus 1 squared. You can leave your answer like that, n plus 1 squared. Okay, moving on to the next one here. This is number 5. Okay, this one looks harder than it is actually. So u of n plus 1 equals 4 times n plus 1 over 2 times n plus 1, and that is equal to 4 times 4 to the n. That's just using one of our earlier examples, our first example, just using those power laws, 2 to the n. Okay, and we can rewrite that as 2 times 4n over 2n. Okay, so you see here pretty quickly, this is going to the ratio here is going to work out very quickly. U of n plus 1 divided by u of n is equal to 2 times 4 2 times 4 to the n over 2 to the n, and we can invert u of n, multiply it and invert and multiply. 2 to the n cancels out with 2 to the n, 4 to the n cancels out with 4 to the n, so we're just left with 2. So it looks harder than it is. It actually, this sequence is like, if you start at 1, is just 2, 4, 2, 4, 8, 16, and so on. Okay, moving on to the next one. 6. U of n equals, this is exam standard stuff now actually I'm getting into. So some of the earlier ones are hard enough. Just actually watch out here. So u of n is 4 to the n plus 1 over 2. Now I'm going to put this in brackets. Lots of brackets here. 2 of n plus 1 in brackets factorial. Okay, so just be careful. I'm replacing n with n plus 1. Okay, so what I'm getting here is 4 over n plus 1 over 2n plus 2 factorial. Okay, so just be very careful with the brackets. When I replace n with n plus 1, I don't get 2n plus 1, I get 2n plus 2. Watch out for that. It's pretty tricky. Let's go and try and solve this now. Okay, so this is actually quite a hard one. So u of n plus 1 divided by u of n. So let's express u of n plus 1 as 4 times 4 to the n. Okay, that's 4 to the power of n plus 1 is 4 times 4 to the n. Over 2n plus 2 times 2n plus 1 times 2n factorial. Okay, so this is the sort of sequence, a countdown: 2n plus 1, 2n plus 2 times 2n plus 1 times 2n factorial. Let's multiply that by the inverse of u to the n, of u of n. Sorry, keep saying u to the n. So this is 2n factorial over 4 to the power of n. Okay. Now, I think we've done all the main parts there. Okay. Just that, again, simplifying 2n plus 2 factorial, the factorial of 2n plus 2, and express it in terms of 2n, we have to sort of do that countdown here. I'll just give you sort of use that example there. 5 factorial is equal to 5 by 4 by 3 factorial. That's just a sort of little counter example there, or a sort of example to sort of rationalize what we're doing here. Okay, let's cancel everything out. 4 times 4 to the n, well, the 4 to the n's cancel out. 2 to the n factorial, or 2n factorials, the factorials of 2n, they cancel out. So what we're left with is 4 over 2n plus 2 times 2n plus 1. Okay, you might and often have to sort of try and simplify that as much as possible. Working that out, you probably might be okay to leave it as is, but if you need to work it out, the answer is 4n squared plus 6n plus 3. Okay, so that is the answer to number 6. Keep a nice steady pace in here. We're getting into exam standard stuff now. So this is for the module I'm teaching. This is the 2007 example, and let's do that. This is 5n over n factorial u of n plus 1 equals 5 to the n plus 1 over n plus 1 factorial. U of n plus 1 divided by u of n equals, let's rewrite this in terms of stuff we know. Okay, so we're expressing 5 to the n plus 1 is 5 times 5 to the n, and n plus 1 factorial is n plus 1 times n factorial. And now multiply that by the inverse of u of n. Okay, and here the n factorials cancel out and the 5 to the n's cancel out, and what we're left with is 5 over n plus 1. I'll just scroll down there. Okay, so that's the answer we're looking for here. I'll keep going. We got 3 more. This is a sort of unusual one. We have the term x here, and that is intended to throw you, but really it's no different to the one we have in the last example where we had 5. It's just x is something else it's not n basically. So u of n plus 1 is x to the n plus 1 over n plus 2. Okay, when you put in n plus 1, where substitute n plus 1 for n there, essentially all you end up with is n plus 2. Okay, so using what we know, again, this can be written as x times x to the n over n plus 2. Simple as that. And the ratio n plus 1, u of n plus 1 over u of n equals x times x to the n over n plus 2 times the inverse of that, of u of n, so x n plus 1. Okay, now that cancels out with that, but really nothing else cancels out. You can't cancel out n plus 1 and n plus 2. So essentially what we have here is x times n plus 1 over n plus 2. And that's it really. Okay, so a couple of more here. I'm just going to finish up. U of n plus 1. These are sort of straightforward enough. This is another exam past paper question. U of n plus 1 equals n plus 2 over 2n plus 1, 2 to the n plus 1, and that is equal to n plus 2 over 2 times 2 to the n. The ratio is that there. Okay, and again, the only thing that really cancels out is the 2 to the n. So in this case, what we have here is n plus 2 over 2 times n plus 1, and that is n plus 2 over 2n plus 2. So that is the answer to this one here. And I think we're nearly finished. Number 10 is 4 to the n over n plus 1 factorial. So in this case, u of n plus 1 equals 4 times 4 to the n. Hopefully we should be quite okay with that. N plus 1 factorial, replace n plus n with n plus 1. So essentially when we put in n plus 1 there for n, we get n plus 2 factorial. Okay, and again the ratio is u of n plus 1 over u of n. 4 times 4 to the n over n plus 2. I'm going to write n plus 2 factorial as n plus 2 times n plus 1 factorial, okay, and multiply that by the inverse of u of n plus 1, okay, over factorial over 4 to the n, and again, let's cancel out everything we can. So what we end up with is quite a lot cancels out there in that particular example. So what we end up with is 4 over n plus 2. And that is all 10 of our examples done. Okay, so we'll leave it there. Done.